Software Engineering Radio, episode 128, Web Application Security with Bruce Sams.
This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 10 days. Thanks to our audience and the partners listed on our website for support. Hello everybody, welcome to SE Radio. This is Marcus speaking. The episode today is a somewhat special episode. It's the first of 4 episodes we recorded live at this year's OOP conference in Munich, Germany. It's not just a conference recording, it's not like on all these other podcasts. We actually did the session as an interview or as a kind of, in between a normal demo and an interview. So this session today is with Bruce Sams, and he talks about software security and web application security. But before we get started, I really want to thank Francis Paulisch and SIGS Datacom. Francis is the chair of OOP and SIGS Datacom is the organizer, for taking the risk to actually do this different kind of session. I think it worked quite well, and the feedback was okay. But still, it was a risk to do it, and so thank you very much for doing that. Okay, we'll have more sessions like that coming along. We recorded 4 sessions at OOP, and today is the first one, as I said, Bruce Sams on software security in the context of web applications. Have fun.
Before we get started with the topic, I guess, Bruce, I think it's a good idea for you to introduce yourself to the audience here and the ones listening sometime.
Good, thank you. My name is Bruce Sams. I'm the Geschäfts President? The president of Optima Business Information Technologies. We're a company here in Munich, a 15-person company specialized in the area of application security. And so what we work on primarily is how do you make web applications or middleware applications secure. We don't do very much really with traditional security like firewalls and routers and all that sort of stuff and network protocols, because this is one of the things we're going to talk about in this session is, in fact, most of the security problems, the vast majority of them are really software problems that have to do with the fact that developers didn't know exactly what they were doing when they were writing the software, or that there are bugs in the software. So that's sort of the focus of our talk today. From the organizational standpoint, I have a demo that I would like to show you. Would like to show you concrete examples of some of these hacking techniques. And then after that, we're going to go over into the interview format.
Right.
First question, how many of you have seen a live hacking demo of web applications being hacked? So a couple of you have seen it. Okay. Good. Then, should we just start?
Just go ahead, yeah.
All right. I hope we have a little bit of time for questions afterwards. We'll see how it goes. All right, so what I wanted to show you, first of all, is just the kind of things that can be done. And when you want to hack a web app, we do this a lot because we do a lot of what we call penetration testing, which is basically somebody hires us to attack their web apps, and then we tell them what we found and how they can correct the problems. So what I want to do here is to show you some of these weaknesses, some examples of problems that can come up in web apps, and then try to relate those to the problem in the software, okay? Because, if you have a problem with SSL, for example, there's nothing that you can do about it, right? There's a problem in the algorithm, forget it. It has nothing to do with you. But the problems that we're going to talk about here are, in fact, software problems. So, first of all, I have a little web application that I wrote here. It's running on this powerful server right here. And we're going to go one time through the application. I'll show you how it works. There are no problems with the application in terms of the specification of what it does, but it's full of holes. It could be called the Swiss cheese application. So, and we know we can trust the people who wrote this application because they have this wonderful little GIF right down here that says they're a FUBAR trusted partner, like having a 5-star thing on the website, right? All you do is save the GIF as something else and pop it into your own website. It's absolutely meaningless little insignia. Okay, so we'll get in this. this website offers cars for sale at incredible discount prices, about a quarter of the original price. Unfortunately, the cars are still too expensive for me. Lamborghinis, Ferraris, Aston Martins, and so on and so forth. But we can correct that, as I'll show you in a moment. So I'll make an order here. The credit card number is not checked, so that's not really mine. I'll order a Porsche, take 2 because they're cheap. Let them be delivered by the local boys. And there we go. Okay, so that's how the application works. From a technical perspective, it's written in Java, although the attacks I'm going to show you don't really have anything to do with Java. You could have exactly the same functionality and the same problems in PHP or in .NET or in Ruby on Rails or whatever. Right away, as a sort of a software security kind of guy, when I look at this, I say, oh, I see 2 places already where right away I would think about attacking the system there. The first one is that in this page it says, "Dear Bruce, thank you for your order." That's part of the reply. And the reason I think it might be bad is that it's some of my input which is now in the output. That's not always a problem, but it happens a lot in websites that you log yourself in enough. On the way through the app it says, "Dear Mr. Smith, thank you for ordering whatever," right? So part of the input is then in the output. The other thing which is a little suspicious to me is this little order ID over here, which looks like it ought to be some sort of a big random number. But if you went to the website and you ordered a lot, you might find out that there's a system to it. And many, many web apps have the following problem. There's a back-end application, and the back-end application is connected to some sort of web front end. But the back-end application, maybe it's an insurance app or something, has got some sort of standard system for giving out policy numbers or the number for contracts. It's the year, the month, the day, followed by an integer that is incrementing or something like that. So it's possible to guess these things. And if the software doesn't disguise that to the end user, it's possible to attack. So anyway, I'm going to copy this thing right here. Since I'm not from Libya, North Korea, or Russia, we can expect this will be delivered very soon. And the application offers us another functionality here, just a little bit. I can put in my tracking number and check the status of my order. Okay, that's it. Super einfach, super simple. But let's look and see what we could do if we wanted to attack this application. Let's just go back, for example, to this and take one of these simple examples that I mentioned to you before. For example, if you went to this app and you ordered several automobiles, you would notice that there's a system to it. And you might be able to put in some different number here and get somebody else's order out. Let's see who comes up this time. Yeah, all kinds of people have ordered cars here. And you'd be surprised at how often this kind of really simple problem occurs in web applications. And it's not that it's impossible to correct. In fact, actually, it's pretty simple to correct with something like a hash table and a lookup table. What you really want is some sort of a standard component for your architecture that everybody can use that says, this is the numbers that you use on the back end, and these are the numbers that you use on the front end. And there's a lookup table between the two of them to make sure that what the end users get is really a random number and doesn't have to do with your internal tracking system, which might be easy to attack. So there are problems that sort of come up because somebody wasn't thinking about the architecture of the system. There are other problems that can come up in web apps just because somebody didn't configure the system right. Like in this case, everybody knows about directory browsing, right? Who knows about directory browsing? I hope you all raise your hands. Thank God. Okay, so we have this directory browsing problem here, but directory browsing can actually be kind of subtle because what happens is that in this case, I've got a combination of directory browsing as a problem, plus I have the fact that somebody was modifying files and left a file on the system called .back. Like one of my JSPs is up there, but in the form .back. Right, so now that I know this file exists, I can click on it. And, because it's not a JSP, it doesn't get pushed through the compiler. right? So I see the quell text. So if you are unlucky enough to have developers that actually comment their code, it doesn't happen to everybody, but it could happen to you. If you're unlucky enough to have developers that comment their code, then what you find here is all kinds of nice information, in this case, about how the database table is looked up and how the tables are arranged and how this JSP goes about getting information out of the database, ... Now, normally, you would say, well, wait a minute, why don't we shouldn't have comments in our web pages anyway. You all know that, hopefully. No comments in the web pages with HTML comments. It says, if you have problems with this page, please call the system administrator, Bob Miller, at whatever number he has. But in this case, it's a JSP comment. Actually, it should be harmless because you should never see it. But you will see it if there's a mistake in the system configuration. Right? So what I'm trying to get at is here, there are a lot of different problems that can come up. You can fix them, for example, with a secure deployment process. In a secure deployment process, this is one of the things that we work on a lot, secure deployment process. You could do something like, for example, make a little scanner. We've got these things that we use, and we use them with our customers a lot. And it scans through all the JSP pages, and it strips all the comments out before the thing even gets to the deployment, right? Then it can never happen, right? Security. Okay, anyway, so we have a lot of different kinds of problems. Let me go back here to another issue here on the main page, here with this check the status of your order. Now, how many of you have heard of SQL injection? Right? Okay, good. So we're not going to go into all of the details about everything that you could possibly do with SQL injection, but it's pretty clear if you're a hacker and you look at this, if you look at this page, you say to yourself, wait a minute, I type in a tracking number, and then the system says, I've got the car, or I've got the order. So probably there's a select in there where the select says, show me the row where the tracking number is equal to whatever it is, this ABXYZ thing that we had for it before. So one thing you can do in this kind of a situation is to type in this kind of a thing here, which basically is true for every row in the table. Because if you have a select statement, and the where clause of the select statement accepts the user input directly without filtering it, then what you get there is you have something like select order where order number is equal to 1, 2, 3, 4, 5, 6. Or 1 is like 1. But 1 is always 1, right? So if we say check status here, then we get the whole table out. And it's amazing how often this kind of problem happens. And it even happens, it happens a lot on login pages, right? What happens if you put in admin as the username, and then as the password, you put in semicolon, hyphen, hyphen. Well, if there's a select clause that says, log me in if for this username, the password is that. If you simply put the semicolon and then the hyphen, hyphen, you turn the rest of the SQL expression into a comment, and it simply logs you in as whatever user you add to the top. You don't have to do anything special at all. You can short circuit the entire login system. So that happens a lot too. There are lots of different kinds of problems. And most of the time, I guess what I'm really trying to get back to here, most of the time, the problem is that we have not thought deeply and not thought for a long time about how to build secure software. It's not that you can't build secure web apps, it's that nobody does. Well, that's not true. Some people do. But it happens more by accident than by planning. Okay, so I'm not going to show you all too many more tricks because this can go on forever. I have dozens of them here. If you want to see more, ask me afterwards. One thing I wanted to show you here, though, was also this famous trick of cross-site scripting. Now, I said to you before that I thought there might be a problem with the web application because it said, after I ordered something, it said, "Dear Bruce, thank you for your order," right? So what it did is it took my user input and it echoed it on an output page. So what would happen if instead of my name, I typed JavaScript in the frame? Well, then on the page, on the confirmation page, it would say, "Dear JavaScript, thank you for your order." But JavaScript gets executed on an HTML page almost everywhere that it is. Not everywhere, but almost everywhere. So that means that if you type in JavaScript here, on the next page, the JavaScript will come out and be executed. And I don't have time at the moment, unfortunately, to go through all of the details of why this here is so dangerous. But I will only say this. Here I'm typing in my name, and I give in as my name a little bit of JavaScript. And part of the JavaScript here is an alert box. And the thing that gets shown in the alert box is that document.cookie. And document.cookie is JavaScript for show me the session ID. So if your web apps do this kind of thing, and a lot of them do, either by accident or by planning, then it's possible for an attacker, through an attack that takes a little bit more time to explain than we unfortunately have here right at the moment, it's possible for an attacker then to misuse this. I'll only show you briefly what kind of thing can happen here. I'll just fill out a few things here. Whoop. I'll say purchase. Okay, so what I've really done here is I haven't really hacked myself. I've looked at my own session ID, not somebody else's. But this is the basic weakness that leads to the ability for an attacker to look at the session IDs of unsuspecting users. Normal, honest users logged into the system can be attacked, and their session IDs can be stolen using this basic kind of a trick. This is a serious problem. And the amazing thing is that it's so insidious and so hard to find. When we do penetration tests, and we do a lot of testing also for companies that have a lot of really, really competent developers and work very, very hard at it, this problem is, I would say it shows up in 85% of the tests that we make. It's almost everywhere. Why? Because this trick, the fact that JavaScript is executed on the page, you can attack the background images in HTML tables, right? And you can attack all kinds of things with cross-site scripting. So it's very, very difficult to defend against. And one of the things we're going to talk about in the interview is how we'd like to get away from a situation in which most of the attacks are then based on having to have the developers do a lot of work. What we'd like to do is to have some sort of a clever system where developers can go ahead and develop software and not spend their whole time worrying about security. They have to know about it, but they shouldn't have to spend all day long thinking about it, because we all know that by the time you've learned the newest version of Enterprise Java Beans, plus Swing, plus Groovy, plus Ruby on Rails, plus, you have enough to do. All right, great. So that's the end of my demonstration. I hope that made it a little bit more plastic and more concrete for you. Now we can go straight to our interview.
Okay. So I guess just a comment on that, I guess one reason why these things are so easy is that the architecture of some of the frameworks and tools are simply flawed, right? I mean, the fact that JavaScript is just text and you can put it in there and there is nothing going on in the background. I mean, it's not about the application architecture, but about the tool, language, framework architecture, isn't it?
I have to look at my answers. Wait.
Yeah, so that was improvised, but we can just go on to the real question.
No, really. Actually, JavaScript works as designed. JavaScript is doing exactly what it was supposed to do. There's nothing really wrong with JavaScript there. It's just the way that it was used in this application, or the availability of the JavaScript there.
Yeah, so, right. Yeah,
you get a lot of problems. You get these. Security is mostly a subtle problem that occurs somehow on the edge of what's considered normal programming.
Right.
That's why people have really not noticed it for a long time now. And one of the problems that comes up over and over again is when you get these complex components that interact with each other. And yeah, I'm delighted, for example, about the new developments in the World Wide Web. Web 2, wonderful. Web 2.0 is great. It's so incredibly complicated, and people are sending messages everywhere, here and there, and then everything's pluggable, and everything is an interface, and everything can be replaced at runtime. It's great for my business, but it tends to make things more complex, and right where all those complex components come together, sometimes you get unexpected side effects.
Yeah. So security is a big topic, all in all, and we talk specifically today about software security in the context of network facing of web apps. So can you outline what software security is as opposed to the whole field?
Right, software security. Now, the important thing to remember about software security is what really plays a difference in software security is the realization that the problems that are facing software today, the problems that are facing all of us with web applications in particular, are not problems that you can solve by putting up a firewall. They're not problems that can be solved by using SSL. Okay? These are problems that have really to do with the architecture, the design, the implementation, and the deployment of applications. It's really something that every software developer and every software architect should know about, at least in their general format. Let me take a second here just to mention that because you asked about it. SSL, why do I say that SSL is not a help? Well, what does SSL really do? If you have a server here and you have a client communicating with the server, SSL makes sure that nobody can overhear the conversation. That's good. That's a great idea. And it also makes sure that the client knows he's talking to the real server, right? To the right one. But suppose you have a client here and you have a firewall here, and then you have you have a server here, the firewall, and then the client. If the SSL goes through the firewall, then no matter what the firewall is trying to do, it can't possibly look at the information that is in the web requests. The HTTP requests themselves, the content of the requests. That's the dangerous part. What I did right there, I just typed stuff into the frame, into the input fields and sent them down. SSL wouldn't have helped at all. Yeah? So it's not something that you can just sort of turn on a switch and it's fixed. It's a difficult problem.
So it also means that it's something that developers need to care about and not the admin guy.
That's right. I think one of the really important things that you have to know is that this is the kind of security that affects developers. It's not the kind of security that you can really push off on somebody else. Here, I have a little slide that I'm showing right now. And this slide shows some recent studies of where security vulnerabilities come from. This study was done in the United States last year by the National Institute of Standards and Technologies. That's a little bit like the German BSI, Bundesamt für Sicherheit und Informationstechnik. And what you can see here is that they went down and they looked at a couple of thousand security bugs and they said, where do these things come from? The answer is 77% of them come from applications. 0% of them come from cryptography. And these little tiny slivers up there, that's things like network stacks and protocols and all this weird stuff where everybody thinks the security is important. Actually, it's fully irrelevant. What's really relevant is the big blotches at the bottom, applications. And of course, application security is not just one simple thing. We don't have a chance to talk about everything here, but application security touches areas such like the infrastructure, requirements, for example, compliance to certain legal requirements, like SOX and the PCI DSS, process security. There are all kinds of standards that might be interesting in that area, testing and quality assurance, and now training.
So we've already seen some hacks that you've shown, some problems, cross-site scripting, SQL injection. What are the top 3 problems, the top 3 issues?
Well, I think the top 3 problems when it comes to software security are related to these general areas that I mentioned before. They are related to issues of design and architecture, implementation, deployment, and also sometimes the runtime environment itself. But probably the top 3 problems are, 1, poor input validation. Actually, there's only one problem. I was recently asked to make a top 10 list of the things that developers have to do when they write secure software, just from the software perspective itself. And I came up with Rule 1, good input validation. Rule 2, see Rule 1. Yeah? Because actually, if you really validate all the input, then nothing can happen normally. You really have an application in pretty good shape if you cover all of the inputs. But the problem is that most developers are not aware of what is really the input to a web app. For example, all of the header parts of the HTTP request are also parts of the input. And lots of applications will read parts of the header or will write their own information into the header that comes up, for example, when you use single sign-on systems. And those can also be very dangerous. Another place is poor configuration. I showed you this thing about the directory browsing before. So poor configuration is also a problem. And the thing about poor configuration is sometimes that the software group and the group that does that organizes and runs the applications and the application servers get at loggerheads about this, because the one says you're responsible for that and the other one says no, you're responsible for that. I say you're both responsible, so you both ought to take a look and see that it works. That obeys the principle of defense in depth. And the last place that I think is really a serious problem in general is that somehow either inconsistent or too complex authorization. Most web apps get the login part right, because it's pretty easy. If you're working in Java, for example, you use JAAS and a little frame appears and you type in username and password. Unless you screwed up with the database so that you have SQL injection or something there, then you can get somebody logged in. But the authorization parts can get really, really tricky. It's not too, that's why I have to tell you, I argue for web apps where the authorization can be really simply explained based on URL paths. You know, the more complex you try to get with your authorization mechanism, so that you say, here is a JSP. Now this JSP can be called by 3 different user groups. Normal users, power users, and administrator. And every time you call one of these different groups calls the JSP, there's a little if-else block in the JSP that says, if you're administrator, show the following links. If you're a power user, then do that, you know? And that gets really complicated sometimes. And although it shouldn't be too hard, people make mistakes there over and over and over again. So I would say if you set up your web app so that either a person can call a JSP or they cannot, that's a lot easier to defend than having them call a JSP, and then the JSP has inside of it all kinds of little if-else switches that say, if you're this, then you can see that link. If you're this, you can see that link.
Yeah.
That's one of the problems that comes up.
Can you remove your badge because it scraps over the microphone all the time?
Sorry. Okay.
Okay, so this is obviously very relevant for web-facing applications, and obviously you've shown many examples of web applications. Is it also relevant for, quote, normal applications like client-server stuff or something?
Yeah. I mean, all of these things play a role. Most of our customers right now are really sort of fixated on the idea of web apps. But I think if you look at the statistics of who's really attacking applications and why they attack, it depends a lot on what kind of company you work for or what you're trying to protect, really. There are a lot of inside jobs. These also here I'm showing, for those of you on the podcast, I'm showing a statistic, a small graph that was also done by an American group in cooperation with the FBI. And the FBI every year in America does a survey where they're called the Computer Crime Survey, where they ask the security experts from different companies, large companies, if they were attacked, by whom, how much it costs, and it's all anonymous, so that the answers we think reflect reality. Anyway, what you see there is that 80% of the companies were successfully attacked by unknown hackers. 77% of the companies were successfully attacked by their own employees. 40, respectively 28% were attacked by the competition, either national competition or international competition. That's like the other companies that are working in the same area attacked them. And 25% were attacked by foreign governments.
Foreign governments.
Foreign governments.
Okay, just asking.
Foreigners, you know. You can't trust them. Yeah. So these dang foreigners are always shooting at you. Right. So a lot of people get attacked by foreign governments. The thing that you can learn about this kind of information is if you look at who's doing the attacking, those are not script kiddies. Those are people who know where it hurts, and they know how to get the information. They have time, money, and resources. So, you know, and it depends on where you're working. For example, in research-intensive industries, it's extremely important to protect against internal attack. Right? If you are in the pharmaceutical industry, or if you're in the if you develop some sort of product where you have a lot of research and development, a tremendous amount of money goes into that, and your competitors would like to know where you are and what new products you're working on. That's extremely important. For some other places, it may be less important. But it's absolutely true that internal attacks should not be ignored. They get usually. The management of a company says everybody that works for us is a nice guy.
Yeah.
On the other hand, if you're a company with 30,000 employees, good luck with the statistics that all of them are great.
Yeah. So, are there any standards we can apply or we can look at to try to get software more secure?
Yes, there are some standards, but most of the people who have tried to apply some sort of a standard to creating secure software have failed miserably. And it makes sense when you think about why they are failing. One of the reasons is that they're trying to get a standardized process and say, okay, that's what you were going to do, right? They want to do like the rational unified process for software. They want to say, this is exactly how it has to be done and not differently. And the fact of the matter is that software and software development is too complex. Some people develop it in-house. Some people send everything out with outsourcing. Some people do a mixture. Some people work then with new languages and new products that, say, are well-suited to agile development processes, and other people are working only with waterfall processes. I mean, it's very difficult to take one standardized methodology. There are a couple of standardized processes that people have tried to use, for example, CLASP. This has the Common Lightweight Application Security Process. CLASP was a product of Rational. They tried to sort of sell it along with the Rational Unified Process, but nobody would buy it because the lightweight in the name does not reflect the actual effort required to implement this process. And now it's an open source thing, and you can get it and download it for free from the OWASP website. Another recent attempt, the Americans have something called Build Security In. This sort of got started, it has nothing to do with our BSI. This thing got started after the September 11th bombing attacks, or the World Trade Center attacks. The American government realized that their software was full of holes. And they said anybody who's going to write software for the government has to fulfill certain baseline criteria. But in this case, it's more a collection of best practices.
Like a checklist more.
Yeah, a little bit more like a checklist. And then there are these horrible ISO standards, which are gigantic and very difficult to handle. And they not only cover software security, but all kinds of other things. And they're very, very big like this. ISO 12207, which is probably the closest thing that it exists to a standard for secure software. This thing is only really useful if you are EADS or Boeing or something like that, or MAN, and you're creating tanks and that kind of stuff. I mean, it's if you make fighter planes, then it's probably not a bad idea. But if your projects are not that big, then it's a little bit overdone. So let me get right here. Yeah, one of the things that I would like to talk about is that there is, we feel, a way to approach this problem of writing secure software, of securing web applications in particular. And I have a diagram here showing various stages of a typical development process. You know, you've got an analysis phase, a design phase, an implementation phase, and so on and so forth. And for each of these phases, what we have done, we work a lot with the secure development lifecycle. What we have done is we have identified individual measures that you can implement. And so what we recommend and what we do for our customers is we say what you have is you have a box full of possible building blocks. And these things have to be then tailored to each company so that they actually fit your development process, because the standard things out of a box just don't work. So it is possible to create software. It is possible to have a secure process, but you have to know what the problems are, and you have to know what measures are sensible to apply to them to fix them. Otherwise, you end up with just more paperwork and unhappy developers, above all. Okay.
So on a buzzword level, you can probably say you have to do secure architecture, secure requirements, secure design, secure programming. Doesn't help. So can you name a couple of concrete things, maybe, one concrete thing in each of these steps or areas that you can do? What is secure architecture or secure design?
Yeah, that's a good question. What is secure architecture? What is secure design? Well, maybe the best way to talk about this would be to look at some of the things that you can actually set up to help you right there. We think that one of the most important things to have is an application security policy. I'm going to ask the developers here, or everybody here, does your company have an application security policy? Who has one? Whose company has one? Really? Okay, so 5 people, 1 out of 10 or something like that, has something like this. The important thing about an application security policy is that's a collection of policy statements about what the security requirements for applications are that is not connected directly to software code. It's not coding conventions. But it's also not so high up the policy level that you get ridiculous statements like confidential data must be protected, right? That's the kind of stuff that's normally in the corporate security policy. It says that, and everybody says, oh, right, confidential data must be protected. Thank you very much. How do I do that, right? So the thing is, you want to avoid really abstract comments in the policy. Don't say things like, we expect you to fulfill certain legal requirements like SOX or Basel II or PCI DSS. And it also shouldn't be in a policy direct usage of things like, shouldn't also be direct usage of code examples, because the code changes too fast and then it's only good for one particular language. What you want is some area in the middle. Normally what is something sensible for that. This helps a lot with the architecture, because you'd be amazed at how many architectural questions can be answered by exactly these kind of policies. What helps is to have an application security policy and derive from that then things like a web application policy or a web service policy that then go into detail about, for example, how to handle SOAP. And if you want to work with the WS security standards like encrypted messages and so on and so forth, what criteria need to be fulfilled. That's a really big step in the right direction. Okay?
Okay. So I guess then training is the other thing, right? I mean, you have to make people aware. Developers, people.
Right. As training is of course extremely important. I think one of the problems with training, generally speaking, is that everybody always nods their head and say, yeah, we should do that. Mm-hmm. Right? But the fact of the matter is that in most companies, what happens is that sometimes a link will be provided and then it says, well, that's not really our core business and so on and so forth. So take a look at this and see if you can't figure out how all that works. And you've seen that demo from the guy, Sam's. Remember where he did that cross-site scripting or the SQL injection? Well, don't let that happen to you. Right. So what's sensible, actually what we find what's sensible is some sort of an awareness training, like maybe 1 hour to 3 hours, depending on who the target group is, where everybody can learn and see what the problems are. Normally in 3 hours, you can tell developers, clever developers, a great deal about where the problems lie without going into the details of exactly how you fix it. And then eventually you can also do things like, for example, set up a training class for 2 or 3 days. We do this a lot, 2 or 3 day training class in which then the developers sit hands-on in a lab and learn about, for example, we have a little casino, a web casino that we wrote. Mm-hmm. So you can play roulette and see how dangerous it is to play roulette. It was brought home to me last weekend when I was on the way back from a meeting and my wife insisted that we go to Baden-Baden. I discovered I'm better at playing roulette in my little software game than I am at really playing roulette. But generally speaking, anyway, in roulette game, in the software version that we have, then you can patch up all the holes with all the software problems like cross-site scripting, SQL injection, and other kinds of things like the Invoker servlet. And so two kinds of trainings are sensible. One, awareness trainings that can be done for a large group, and then also in-depth training for developers.
And I guess it's also useful to have some kind of, a team that tries to break into the software, like a red team that plays the enemy and then tries to break into systems you build.
Right. Yeah, there's a definitely a utility there. I think every company has to try to figure out for itself whether or not the relative costs of trying to maintain such a red team are really sensible. In theory, you could say towards the end of the development cycle, right? When you get to the beta version of the software and you're ready to roll out, or you have your last things. In theory, you could then take 2 or 3 of your best developers from the project and say, okay, now guys, I want you guys to do security testing and code review. And I would like you to show me the project manager that in the hottest phase of the development, right before the thing's about to be sent out the door, that the project manager that takes 2 or 3 of the best guys on the team and says, okay, sit over there in the corner and do something different. Forget it. It will never happen. Yeah. It's just pure theory. It can never work. I've never seen it work. And that's where either a company has to say, we're going to make a big investment, or we're going to have a totally independent group, a totally separate entity in the company that does nothing but QA. And there's this little bit of, I wouldn't say animosity, but they're not really friends with each other. The people who do the testing are really independent. That means if one of the best friends of the guy on this testing team was the lead architect, he still says the thing has got big holes in it. Yeah, that's not so easy to work out sometimes in companies. That's where external companies can be helpful.
Do you know, just out of curiosity, do you know companies like security, banks or something who have such teams, or is it really too expensive and typically people do it by hiring outside guys?
Typically people do it by hiring outside people.
Okay. Which also solves the best friend problem.
Which solves the best friend problem, and which also solves the problem of having to make sure that those people are really constantly learning the new things. So for example, my employees get about 25% of their time for research. I just say, I don't know what you're doing, but do something useful and figure out how to break that. How should I know? I mean, but you have to keep learning all the time. And that's usually not part of the corporate culture in larger corporations. It's
a little bit unfair, right? That most of the approaches to solving that problem is basically burdened on developers. I mean, you would have hoped that there would be some other way.
Yeah, it is unfair. And that's why we believe that it's important to set up this software development lifecycle with every company that's interested in producing secure software, so that the developers have knowledge that they need, but that nobody comes to them and says, hey, I saw this talk where they do a lot of hacking from web apps. I want you guys to really think about that and write secure software from now on. How? And with what time? Because it requires the management has to say, it's going to cost us 10% more to write the projects from now on because we need time to do that. And normally that's hard to get when people are under pressure. There are tools that you can get to help you with writing secure software. How many of you know and use FindBugs or use FindBugs? Okay, about 30% of the people in the room raised their hand. FindBugs is just one of a whole class of different kinds of applications that you can use that will help you with software quality in general. They'll find things like cyclical references and loops that go off into nowhere and all kinds of stuff, in addition to finding security problems. It's difficult to really do a security test with these automated tools completely, partly because FindBugs is not really, or the other things are also not optimized for finding security problems, and also because sometimes security problems are very subtle. I don't have time, unfortunately, to get into that in detail right now. If you're interested in it, come and talk to me afterwards. But the bottom line is that most of these software tools will also produce a certain number of false positives, and false negatives. So they don't find problems that are there, and they also indicate there are problems where there are none. and you need to really have a fair amount of experience with the tools to be able to understand what the thing is telling you. You know, it's that old story that a fool with a tool is still a fool.
Sure.
I can say that because I'm a developer also. So I don't mean that developers are fools. I mean, it's just another thing to know and learn.
There are tools, I think, that do, for example, tracking of inputs and you know, tell you whether they have been validated at some point.
Yeah.
Right? So does that stuff work? Have you used it? Or?
Yeah, actually, we have our own tool that we wrote that does that kind of stuff, but we don't sell it.
Right.
It's not a product for sale. It's a research tool that we use. And but there are tools that go in that direction, and how good they are varies widely depending on what they're trying to find.
Yeah.
Here I have a little Dilbert, which I'm just going to flip through here quickly. Dilbert is sitting in front of his desk, and somebody comes to him and says, "Dilbert, do you have the benchmark results?" And Dilbert, typical nerd, says to his partner, he says, "Well, do you want the 10-minute explanation of why the data are useless? Or do you just want a simple, here you go?" The guy says, "I'm in sales." Here you go. Okay, so yeah, it's tricky with these tools and so on and so forth.
Yeah. So we have two more topics. One is a horror story.
I forgot the horror stories.
Yeah,
right, the horror
but you
stories.
can also do the web firewall thing first, if that's your next slide. I don't.
Yeah, why don't you do web app firewalls, and then I'll tell you a couple of horror stories. They're always amusing.
Right.
Okay. Well, you know, at the beginning I said firewalls can't protect your web applications. And that's true. A classic firewall cannot, because a classic firewall, it protects networks, but it doesn't protect applications. Now, there are a series of new products, which some people call them web shields. You'll find them under different names. We call them web application firewalls. And those are special products that understand HTTP very well, and are also capable of analyzing the stream of data flowing to a web application. And, you know, for example, when I did cross-site scripting, then I had as one of my input parameters in the input stream, there was JavaScript there, right? Or you could see the tags, the little the brackets going open and closing and so on and so forth. Conceptually, a web application firewall is a filter that looks for that kind of problem. And you can put up web application firewalls in front of your web applications, and what the producers of web app firewalls will promise you is you turn the switch, and no matter how crappy your software is, pardon my French, English, no matter how poor your software is, this thing will protect you because it filters out all the bad stuff. If you're interested in this, come and contact me later. We just completed a 6-month-long study where I had 2 guys in the company, and I set them on web application firewalls, and they looked at 7 products and analyzed what they can do and what architecture and what the performance was and all that kind of stuff. And we want to publish this thing pretty soon. Just haven't gotten around to it because it was just finished before Christmas time. But the bottom line is this. You can use a web application firewall. It's a good idea, but web app firewall is no substitute for writing good software. What you can do well with a web app firewall is what I call zero-day patching, right? One of the problems that comes up over and over again, particularly with web applications, is when we do a penetration test on a web app and we find a critical vulnerability, then the management of the company says to us, well, what should we do?
Rebuild the system.
Should we stick our head in the sand and use the ostrich approach? Should we turn off the web app and just take it off the net? How do we handle this problem? Or should we tell our development team to get together in a big hurry and they'll write a patch tonight and tomorrow it's in? First of all, patching software in a big hurry is often very, very difficult, and you make more problems than you fix, or not always, but it can happen that you also then create new problems, or that the original team that wrote the software is not really available anymore because the software is already 2 years old and the team is all spread out. So you can't patch sometimes really fast, and you don't want to take your important application off the web, particularly if you have to have a big sign that says, due to security problems, we had to take this off the web. Right? So that's really bad. But what you can do with a web app firewall, and this is really great though, is you can, if you have practiced with the web app firewall, you know how it works, then you can set up the firewall with just one single rule in it. So the performance is good. Simply put, the more rules you have, the slower the performance. Sometimes you get these regular expressions. I mean, your eyes will pop out of your head when you see these regex. You know, it's like 20 lines long of regular expression. Good luck, right? The thing is really complicated. But if you write a single rule and you stick it in the firewall, you can put the web application firewall right in the way and block that one problem that you know about.
In other words, if what you're saying is if you know what you're looking for,
yeah,
specifically, then it's useful, but not as a general purpose catch everything. That's mine, by the way. You have the same one, I know.
Okay, right. That's exactly it. All right. So now I've told you that I have 1 or 2 moments left for horror stories. There are a lot of them.
Pick a funny one.
But everybody has to be anonymous in these horror stories. That's the interesting thing about them. Good. I can tell you a horror story that has to do with what I would call developer craziness. One that has to do with sort of developer ignorance, and one that has to do with the fact that there was no quality control. I'll go through them real quickly. Developer craziness. We had a penetration test where it turned out that the developers had wanted to be able to operate this program from home without having to come in and actually do the administrative work from within the company. So they put a little extra hidden parameter. All you had to do to the web app was add admin equals true to the URL, and you were in administrator mode.
No password.
No password, nothing. Right, but here comes the best part. It was a bunch of guys. Okay, sorry, girls, I have to tell the story. It's a bunch of guys, right, young guys, and so they were a little bit bored, so they took the background of the whole thing, and they had about 25 pictures of blonde women in various poses, I would say, and they were loaded up to the corporate web server, and there was a little random number generator, and every time they called up the administrative website, they got a different one of these things as the background with the corporate logo above it. Don't do that, okay? That's what I call developer craziness, yeah? Developer ignorance. We had recently a pen test where the developers were using Cocoon. Nothing wrong with using Cocoon.
What's that?
Cocoon is a web framework that transforms XML into PDF or into input fields. It's sort of a, and they didn't bother to remove the error messages, or they didn't bother to remove the message at the bottom of the page, because when I first called up the website, I looked at it, and at the very bottom it said, this page generated in 68 milliseconds by Cocoon 1.8, whatever, I forget. I thought, oh, Cocoon, doesn't that come by default with the administration console installed? All I had to do was call up then the same URL and put in the standard path to the administration console, and I could administer the entire Cocoon installation. Pop out the XML files, change the whole thing.
But isn't it either a hosting problem than an application development problem? So
it's both. You're right, it's both. But to me, it's a development problem because the developers are the ones who would have to say in the Cocoon itself, don't show me those files, don't show me those messages. They would have to block that out.
So they gave the hint for the
and that was what gave me the hint that Cocoon was installed at all. Otherwise, I would never have known. Yeah, they could also have done that. But exactly, there are many cases, and I'm glad that you mentioned that, because in many cases, as I mentioned at the beginning, like with this directory browsing, you know, instead of having the developers arguing with the production group saying, hey, it's your fault, and the other guy says, no, that's your responsibility, why don't you both do it? Because defense in depth says 2 hurdles are better than 1. The last story I wanted to quickly mention here was something where there was high-speed development involved. A company went to their contractor and said, we need to have an application that has to manage our stocks and equity stuff, but it has to be written in a big hurry. Or what, you know, some big boss said, the other company has it, we have to have it too.
Yeah.
So they hired a company. The company did rapid prototyping, and the entire web application could be. It had no security features built into it at all. It was possible to log in to the web pages using this SQL injection thing. You could log in as administrator and completely manipulate the entire website, but nobody had even bothered to do any real QA testing because they were in such a rush. That's why it has to be part of your process, because if it's not part of the process, I guarantee you the management will ignore it.
Right. Okay, do we have any questions? And before you ask them, I have to run to you and give you my mic. So any questions?
But anyway, thank you very much. Thanks for the nice discussion.
Sure, but we still have, we should, 5 minutes or something.
5 minutes,
6,
okay,
7.
great.
So, questions?
Any questions?
That's not very professional, but it's going to work. Hi. So if you're using frameworks like JSF, standard frameworks, does it help you doing the input validation or, for example, Hibernate? Can you rely that it helps you preventing SQL injection?
Absolutely. We also noticed that the web frameworks in general are also improving a great deal, that they do a lot more for security now than they did at the beginning. Like if you look at early versions of struts, for example, had very little to offer in the way of security, where Java Server Faces, for example, offers quite a number of good ways to do validation. And there are also frameworks that you can use now. For example, the Apache Commons Validator framework is a very good framework, which needs to be extended, but which is good, basically. You mentioned Hibernate. For example, Hibernate, normally when we find an application that uses Hibernate, we can't do any kind of injection on it. I mean, it's not a guarantee that it won't work, because it's still possible for somebody to be really boneheaded about using Hibernate and to basically write HQL, and then you can do HQL injection on the application with the Hibernate query language. That can happen, right? But if you go over the typical kind of architecture where all the calls are parameterized,
right,
then it can't happen to you. So unless you sort of have your own clever way to use it, you won't screw up. Hibernate is basically great.
So that's a concrete thing. Don't build your SQL by assembling a string, but rather use parameterized SQL queries, pre-built statements.
Exactly.
More questions?
Any other questions? Okay.
Well,
perfect timing.
Absolutely. Thank you very much for doing this.
Well, thank you also.
Thanks.
Thanks for downloading and listening to Software Engineering Radio. Software Engineering Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example by clicking on the Dig, Reddit, Delicious and /dot buttons. To contact the team, please send email to team@se-radio.net, or if it is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under a Creative Commons 2.5 license. Please see the website for details. Thanks to Charlie Crow and the PodSafe Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.